We have solved one type of aggregate plan, that is using the graphical or the charting method, where we plotted a histogram as well as we used a regular graph in order to understand what will be the average production, what will be the kind of production rate if there are no back orders, etc. Now we have to go on to what are the mathematical techniques. So generally the mathematical technique that we use in general to form an aggregate plan is the transportation model, and here we use the least cost matrix method. So because you have not gone through what exactly a transportation model is, what exactly a transportation problem is, it is something that is covered in a course called Operations Research, and here it is included in a course called Operations Research, which you have not yet gone through because it comes in the 8th semester of the VTU syllabus. So before we move on to solving a problem or creating an aggregate plan using the transportation model, let me just take you through a brief introduction as to what exactly is this transportation model, why do we use it, and how do you actually solve a problem using this technique. So the transportation problem, like I mentioned, is a mathematical technique. It is a technique that is used to choose the best kind of transportation method to move one thing from one place to another, to put it in general terms. So if at all we have some sort of a source and we want to move something from this source to a particular destination, we use what is called as a transportation problem. So what happens here is, this source could be a warehouse. It could be a warehouse, and this could be, the destination could be either the shop floor or it could be customers or whatever it is. So when we're talking about movement of material from one source to a destination, we use what is called as the transportation model or the transportation problem. Now exactly what does this problem look like, or exactly how do you formulate a problem in this fashion? So here understand that you will have various sources and you will have various destinations. So the sources will give you how much of supply is available. In other words, in the warehouse, I will have information of this much raw material, so much of inventory. This is in the warehouse or within the factory or wherever you are taking from for the, or whatever you are considering to be the source. So when you consider the source, it will give you how much supply is available. This supply has to be sent to the destination to fulfill what? The demand at the destination. The destination will say that I need this much of product, I need these many products, or this many pieces of raw material is required. So now, in order to be able to solve these kind of problems, we need to formulate whatever we are going to solve into a matrix. Now these matrices will be a matrix that is formed from the source to the destination. Now, like I told you, that whatever we are taking from the source is the supply, and whatever we are sending to the destination is the demand. We are fulfilling the demand at the destination. So what we need to understand here is, a transportation matrix or a transportation problem deals with the costs that are incurred while carrying out this process of transferring from supply to demand or source to destination. So when we create a matrix, the matrix that we create is a cost matrix. So all that it is going to tell us is, if I take a certain source, if I consider a certain source, and if I take some raw material or some material from that source and send it to the destination to fulfill the demand required, I will be incurring some amount of money. There is some sort of cost that is attached with it. So how much will it cost me to send a certain amount of material or carry out a certain operation from here to here? So when I form this into a matrix, the matrix will carry all the costs related to this particular operation. So I'll just give you an example as to how a transportation matrix looks and how we can solve it. Because before we move on to creating an aggregate plan with transportation, you need to understand the basic logic behind transportation problem. So I will take a certain example. So if I have some sources here, I'm going to list some sources. I say that I have a source A, I have a source B, I have a source C. Okay? And then I have some destinations here. I have some destinations here Destinations in the sense where the demand has to be met, and I call those destinations as 1, 2, 3. I have listed the sources on the left side of the matrix, and I have listed the destinations on the top of the matrix. So here what we need to understand is, from this source I need to send material to these destinations, from any of these sources to these destinations. Certain rules that apply here is, whatever supply, or it's rather not a rule, it's more like an assumption, but we use it as a rule in order to be able to solve a matrix properly and generate proper plans. So in which case, what we have to assume is that whenever we are taking material from a source to a destination, you need to carry out whatever iterations you're going to carry out in solving the problem till every single supply is exhausted and every single demand is met. Till every single supply is exhausted and every single demand is met. So what do I mean by this? This is a source A. I am saying that there is some sort of supply at A because it is a source. This is a source, so it has a supply. So A has certain supply. These are destinations. So destination 1, destination 2, destination 3, there are certain demands that I need to meet at these destinations. So the matrix will look like this. This is what the matrix will look like. Okay, so I say that at source A there is some supply, at B there is some supply, at C there is some supply, and at 1 there is a certain demand, at 2 there is a demand, at 3 there is a demand. So I'm going to fill in this matrix for you to understand what the problem looks like. This is an example problem that I have considered only to give you an idea of what transportation is. So at source A, I say that the supply is 70. That means I have 70 units available at source A. At source B, I have 30 units at source B. At source C, I have 50 units. This is the information that is available to you, that at each and every source, this much supply is available. Now, moving on to the demand that has been placed. At destination 1, they require 65 units. At destination 2, they require, say, 42 units. At destination 3, they require 43 units. This is again information given to you. You need to fulfill all these demands taking material from the sources. Now, again, information given to you will be the costs. How much will it cost for me to take something out of the supply of 70 and send it to destination 1? How much will it cost me to send something from A to 2, A to destination 3, B to destination 1, B to destination 2, B to destination 3, C to destination 1, C to destination 2, and C to destination 3. This information is also given to you. So to make an assumption for this particular problem, we just assume that it costs about 5 rupees, 7 rupees, 8 rupees, 4 rupees, 4 rupees, 6 rupees, 6 rupees, 7 rupees, 7 rupees. This is just an assumption that I have made. Simply means that for me to move something, any amount of a unit from source A to destination 2, for example, I am going to pay 7 rupees per unit. Okay, I have 70 units here. 70 units, I am going to take out something from the 70 units and send it to destination 2. Whatever amount I take out per unit, I will pay 7 rupees. That is the meaning of this matrix. Okay, so now before you solve the transportation matrix, this is how it is. So all the information may be given to you in the form of a statement, as in our aggregate planning problem, and you might have to formulate this matrix. It is very simple. You have to list the supply on one end and list the demand on the other end. Okay, the other information given to you in the problem go inside the matrix, which are all the cost information. Fine. So here, before we solve this problem, I will tell you exactly how you have to look at the problem. For any transportation problem to be solved, there is a condition the problem has to be balanced. So you need to ensure that the transportation problem you are solving has to be balanced. What do we mean by balancing? The balancing means that the total supply should be equal to the total demand. So when I'm talking about balancing this or the supply equal to demand, what you need to do is whatever supply information you have, you need to total it. Whatever demand information you have, you need to total it. And both of them should be equal. If they are equal, the problem is balanced. If not, I will tell you the next kind of condition. But here for now, let us just total this. So when I total this, I get 150. Okay, and if I total the demand, I get 150. So it is balanced. Now that the problem is balanced, we can proceed with whatever solution we want to get. Please note that while solving a transportation model, there are various methods which we can use. But in this session, just to introduce to you what is the type of logic that we're going to use for the aggregate planning, I'm only going to take you through the least cost method or the least cost matrix method. So here I'm not going to go through the other two methods that are available that you will learn in a different course. But for now, I'm going to take you through the least cost logic or the least cost matrix method. What do we do here? I told you that the aim of the transportation problem is to take material from the supply and satisfy the demand at the destination, right? So how do we do this? We need to do this in such a way that the total transportation cost that we incur at the end of the whole transportation assignment is the least possible. So how do we know that it is the least possible? Again, like I mentioned earlier, you have verification methods, but we are not going to carry out any of that here. So just to give you the simple idea, what we're going to do is, for example, if I need to take something from source A and that is out of its supply of 70 and satisfy a demand at source B, I need to understand how much of cost I'm going to incur because it is 7 rupees per unit. I cannot take out all of them at once. Right? So I will tell you how exactly we carry out these allocations. Look at this portion of the matrix, that is the cost portion of the matrix. Just observe the cost portion of the matrix. So when you look at this cost portion of the matrix, that is ignoring the supply and the demand for now, pick up the least cost in the entire matrix. Look at these numbers from among 578, 446, 677, you need to pick up the least cost. So here when you observe this, you see that there is a least cost of 4. Now what do I do when there is more than one 4 in the matrix? You pick any one. If there is a tie, pick any one. Okay? So I'm going to pick up this first one, which corresponds to supply B or source B and destination 1. Destination 1 is the first column, supply B is the second column. So I'm going to pick up this 4. Now once you pick up a cell, you have to look at the corresponding supply and demand values in that cell. So if I've picked up this cell, look at the supply in that cell, it is 30 and the demand in the corresponding cell is 65. Now what you have to do is, comparing these two numbers, pick up the least number of the two. So here you pick up least number of between 65 and 30. When you pick up the least number between these two, obviously it is 30. I will just draw a small rectangle on top here and write the number 30. What does this mean? I have taken 30 units from the supply to satisfy part of the demand here. Right? The demand is 65. Supply is 30. Suppose I had picked up the greater number and written 65 here. I don't have 65 at supply B. I have only 30. Destination 1 wants 65. Supply B is giving me 30. I will take the 30 from there, assign it to the least cost here. How did I pick this least cost? From among all the matrix elements, right? So I have assigned 30 at this point. This simply means that I have exhausted this supply. I don't have anything left with me at source B. So I cannot take out anything, or rather I cannot satisfy demands to destination 2 and demand to destination 3 from supply B because supply B is exhausted. What has happened here at the demand for destination 1? I have satisfied 30 units. That means to say the difference, because I have already fulfilled 35 or used 35 units here, I am only left with 7 units to be fulfilled here at the destination 2. Then again we are having 2 more, that is 7 and 7. So you can choose either one. If I choose this one and I allocate between 50 and 7, the least value is 7. So I have finished this particular destination, and here I am left with 43 units. Okay, I am left with only one cell over here. Demand is 43. Supply is 43. I am done with my allocations, 43 units. Every source is reduced to 0. Every destination has been fulfilled with its demand. If you choose, you can try it by yourself. If you choose any other cell as well, you will get the same kind of answer. Okay, so the answer to this solution, to this problem, the answer to this problem lies in the fact that you need to fulfill all the demands at every destination using every single supply. So at the end of the problem, all the supplies should be changed to 0 and all the demands should be changed to 0. So all of them, until they become 0, you continue to carry out the iterations. You continue to carry out the iterations. If it is a balanced problem, it will happen like this. After we have carried out this problem, what do we do with it? How do we find out the total cost? What you need to do here is, you need to multiply only the cells which have been allocated. That means to say that this final matrix means this. From source A, I am going to take 35 units out of its 70 units and supply it to destination 1. Then I will take 35 units and supply it to destination 2. I am not going to be sending anything from source A to destination 3. Similarly, I am going to take 30 units, all the 30 units from source B, supply it to destination 1. Destination 1. I am not going to be using any units from B to go to 2 and 3. This is according to my iteration. Now it all depends on you and how you have taken the least cost. Similarly, C goes to 2 and 3 accordingly. Okay. So how do you find out the total cost of this? We will just multiply the total cost is equal to, you multiply the cost in the cell with the number of units that you have allocated to that particular cell. So I have allocated 35 units to a cell which costs about 5 rupees per unit. So 5 into 35 plus 7 into 35. Here there is nothing, then here plus 4 into 30 plus again 7 into 7 plus 7 into 43. This is the total transportation cost that I will incur when I carry out this kind of an allocation. Okay? So now, what do we do when the problem is not balanced? I will not solve another problem. I will just write another matrix to make you understand the difference. So if I have 3 sources A, B, C as in the previous problem, and I have say 5 destinations, 1, 2, 3, 4 and 5 destinations, supply is given to me, demand is given to me. Supply is given, demand is given. The supply that I have, for example, is say 8, 12, 14, and the demand that is there is 4, 4, 6, 8 and 8. When I add total supply, I get 34. And when I add total demand, I am getting 30. The problem is not balanced because the total demand is not equal to the total supply. And for us to be able to solve a transportation problem, it is very important that this happens. So here we are short of 4 units. That is, here you are having the greater value is 34. So you need to subtract these two and see the difference. Now the difference is in the demand. The demand we know is represented at the destinations given by columns in the matrix. So you need to add a dummy column. We call it a dummy column or a dummy destination which has no significance on our final output or our final answer, but it definitely helps to balance the problem. How do you write this dummy? The dummy is written and the difference between the supply and demand that we have seen is entered there, is entered in the dummy there below. The rest of the entries, unless otherwise specified, is 0. Which means to say, even if I carry out allocations, which I will, you will carry out allocations to the dummy column or the dummy row, but the allocation will have no significance because the entries are 0. Please understand one more thing, that if at all the shortage was in the supply, for example, if it was the reverse, if it was 34 in the supply, if it was 34 in the demand and 30 in the supply, supply is represented at the sources, which are all given by rows in the matrix. You will add a dummy row and then the difference will be added there in the row. Okay, so this is how we deal with a problem that has a shortage in the demand or in the supply. You need to add a dummy column or a dummy row in order to balance the problem. The difference between the two which has occurred in the totaling will be entered against the dummy column or the dummy row, and allocation is carried out in a similar way. So I hope that the basic logic of the transportation problem and its model and the way we are using the least cost matrix method is clear to you. It is the same logic that we will be using to solve our aggregate planning problems. The problem that we are going to solve reads like this. The supply, demand, cost and inventory data for a company which is at a constant workforce is given for 4 months in the following table. The company wishes to meet all the demands without permitting back ordering. Allocate the production capacity to satisfy demand so as to minimize the total costs. Also, find the minimum basic cost for meeting the demand using the least cost method of the transportation model. If in the same company, back ordering is permitted, then what is the total cost if this back ordering is allowed at rupees 10? So from the two tables that are given to you, one is the supply capacity in units and the other is the demand forecast. You need to use the same principle that we learned in the transportation model that we learned earlier. So here what we're going to do is we are going to formulate the transportation table. I have already written the headings in the table. One is the supply in units. Please note that this is the supply in units that means from the source or from one period to another. So here always remember that it may not always be given to you as a source and a destination or as from one place to another. It can also be given to you as, or you can also formulate it for time periods. That means from January to December or January to February, February to March, or annually, 1 year to another year, 1 week to another week. So when you are talking about something from somewhere to another place, then you're going to use the transportation model. Okay, so here the supply units and the demand and the maximum availability. This is taken from the supply capacity table. What does this table mean? The table simply means that in the month of Jan, the supply capacity for regular time working is 60 units, 20 units for overtime and 1000 units for subcontracting. This is not a cost, this is the units available. In other words, what we are trying to say is that in a regular working time, there are 60 units of work units that are available. That could be manpower, it could be time available on the machine, it could be anything, but we're talking about 60 units. Okay, so that is the supply capacity in units that's given to you. Then we have the demand forecast. This is telling you what is the demand in each month. So in the month of Jan, 100 units are required, February requires 50, March 70 and April 80. Along with this, cost requirements are given. So these cost requirements have to be incorporated into the table. So when we start from here, the supply in units is given. The demand is also given to us for various time periods. So that we will write here. The demand is given to us for January, It is given for February, for March, April. It is given to us for all of these months. So here, this is the demand column. Now, incorporating the costs, we know that clearly it is given here that the initial inventory, before even production begins in the month of January, there is an initial inventory. So the initial inventory is entered here as a row. Before production begins, the initial inventory available is 20 units. That is already specified. So this 20 units is already given to us in the cost information given below the tables. So 20 units is already available. Then in the month of January, regular time, overtime, subcontracting. This is the information for the month of January. Similarly, you have the same kind of information for February, March and April. Regular time, overtime and subcontracting. What is the availability? Regular time availability, take it from the supply capacity. For the month of January, regular time availability is 60, overtime availability is 20 and subcontracting time is 1000. So you write here, subcontracting 20 and overtime 20 and subcontracting 1000. So this is the information for the month of January. What have we done? From the supply table, we have taken information for the month of January. Similarly, you write it for February, March and April. So February, regular time, overtime and subcontract. It is 50, 15 and 1000. For the month of March, regular time, overtime, subcontract, 60, 20 and 1000. And then for the month of April, again regular time, overtime and subcontract. You need to write the values 65, 30 and 1000. Next, from the demand table, you need to list the demands for each of these months. So the demand for the month of January is 100 units. So below the month of January, you just write down 100 units. For February, it is 50. March, it is 70. And April, it is 80. Go on to the cost requirements that we have, or the cost information that is given along with the inventory information. It has been stated that the initial inventory that you have available when you're starting the production is 20, and there is a condition that at the end of all the production terms, that is at the end of April, that is 4 months, 25 units has to be available. So when you're writing it for April, it is April plus the final inventory of 25 units. So here 80 plus 25 giving you 105 will become the demand for the month of April. Now what you need to do is, like I explained in the transportation model, you need to total both the supply and the demand, make sure that it is equal. If it is not equal, then we need to balance this transportation matrix with the difference between both of the terms. So that means the total of the demand and the total of the supply, both of them have to be equal. If not, they need to be balanced. So when you total this supply, you get an amount of 4340, and when you total the demands, you get total of 325, which makes it short than the supply. So what do? We add a dummy column. Why do we add a dummy column? Because it is a demand that is short, that has the shortage and not the supply, in which case what we are doing here is we are adding a dummy column, and the difference between the two, 4015, is added to this dummy column. The remaining information that we are going to fill here is the cost information. So what does this mean? Starting from the initial inventory row, you understand that there are 20 units available when production is beginning. Now, if we use all of this information, if we use those 20 units that are available in the month of January, we don't have any costs that we are going to incur. That means we are going to sell all of it. We don't have any extra cost that we are going to incur. Further, if you see, there is something called as a carrying cost that has been given to us. So carrying cost is of 5 rupees. Instead of using it in January, if any unit is remaining unsold or has remained from the month of January, then the initial inventory units that I'm talking about of 20 units, if all the 20 are used in Jan, we don't have any amount that is incurred. If we take it forward from January to February, even a single unit is going to cost us 5 rupees, because it is mentioned that carrying cost is 5 rupees. So again, further, if it goes from February to March, it gets added on with another 5 rupees, that is 10 rupees. Okay, so that keeps going on till April, when it becomes 15 rupees. So if it is all sold in the month of January, it is 0. If it goes on to February, an additional cost of 5 rupees is there. And then if it goes on to March, again 5 rupees gets added. And if it goes on to April, 15 rupees. Now because we have a dummy column or a dummy month, we will add another 5 rupees and say that it goes up to 20. That means if it remains after April, again we are incurring a cost of 5 rupees extra. Now if we try to write the costs for January, February, March and April according to what is given to us, regular time cost for every month is 100. So if all the products that are produced in regular time, 100 rupees. If it is produced using overtime, it is 125 rupees. If it is produced using overtime. If it is produced using subcontracting, it is 150 units. See, please understand that each and every unit that is mentioned here is a per unit cost. So per unit in regular time for the month of January, it is 100 rupees, 125 for overtime and 150 per unit for subcontract. Now, if all the units that are produced in the month of Jan are not sold in Jan, and then we have to carry it on to February, that means to say that if you want to carry out, you have not completed production here or not completed sales over here, and it is going to be carried on to February, then what you need to do is you have to understand that there is a carrying cost that has been told to us. If units are not sold here and units have to go on here, regular time utilization, if it is carried on to February, gets an addition of 105 because carrying cost is 5 rupees. So you add 105. This becomes 130, this becomes 155. Why does this happen? Because production is not completed here or sales is not completed over here. So if I carry on anything from January to February, I am going to incur 5 rupees. If I carry anything from February to March, it is going to become 5 rupees addition again. So 110, 135, 160. If this is carried on to April, 115, 140, 165. Now going into the dummy, We really don't know because this is the end of the term. This is the end of the term. At the end of this term, if there is any regular time remaining, then it is going to cost us, unused regular time is going to cost us 50 rupees. So if there is any regular time that is unused, I am going to write 50 if it is carried forward. Here, overtime and subcontracting, I am not going to have any costs related to them if they remain at the end of the term. So that is why I am entering 0. Now even if this 50 was not specified in the problem, then you will have to have the dummy column with the entries all as 0. So similarly, if we write for February, here February, the next column that you have to fill or the cell that you have to fill should correspond to the month of February, because here we are not talking about January. From February you can't come backwards right now. February we are moving here. Regular time cost in February is 100, then 125 and 150. If production is not completed or if orders are not fulfilled in February and carried on to March, then an additional carrying cost of 5 rupees is added. So here it becomes 105, 130, 155, 110, 135, 160. And here, if you have any regular time that is unused, it is an additional 50. And here you have zeros because we don't have any cost if there is unused overtime or unused subcontract. Similarly, writing it for the month of March, again we start with 100, we move to 125 and 150. If it is carried forward, it is 105, 130, 155, 1, and here if it is remaining it is 50, 0 and 0. For the month of April, 100, 125, 150. At the end of the term, 50, 0, 0. What does this table mean? Unlike the previous transportation table, everything is not specified. So what do you have here? You have initial inventory given to you. You have the time periods given to you. So from one time period, corresponding time period, what are the units available? From one time period to the end of the time period, if it is remaining, what happens? So this is the information that is given in this table. We had to add a dummy column because the total of all the maximum availability or supply was more or greater than the demand at the destination or at the end of the month. So the destinations, like I said, need not always be a go down or a customer. The destination can also be the time period. The source or the supply need not always be a warehouse. The source or supply can also mean a time period from this time period to the next time period. We use the same logic to solve all the problems. So now we will move on to solve this problem using least cost matrix method. To solve this problem, we have the same logic as the regular transportation model, but it's slightly different when we are solving it or creating an aggregate plan using it. So like we saw in the least cost matrix method, in the entire matrix we picked the least cost. There we were dealing with sources and destinations, that's it. Here we are dealing with time periods. One thing we need to understand is that when we are carrying out an aggregate plan, when we are trying to create an aggregate plan, one major thing is that from one time period to the next, if there is any carryover, we incur losses or we incur some sort of costs. So we need to make sure that whatever planning we are doing, it is to fit the regular time period that we are talking about. So to solve this problem using the regular matrix, least cost matrix method, what we do is we consider individual time periods as a whole matrix. In other words, to solve this, I will start with the first time period, which is January. So looking into the month of January alone, I am not taking any other month into consideration right now. First, starting with the first time period, which is January, among all the costs in the month of January, you pick up the least cost. So here we can see that the least cost is 0, which is against the initial inventory row. And then you compare supply and the demand as we do in the regular transportation problem. So here it is 0, the supply is 20 units and the demand is 100 units. I cannot take more than 20 units because I have only 20 units and 100 units is the demand. So I can fulfill part of this demand using those 20 units. So what I do here is I just put a box around 0 and I will allocate 20 units here, exhausting this supply. And in the meantime, what happens here is I have fulfilled part of the demand to 80. So 80 more units need to be fulfilled in the month of January. I have exhausted the inventory supply. Okay. Next, you pick up the next least element among the costs here, 100, 125, 150. So 100 is the least. You put a box around 100. Compare the supply and the demand for 100. The demand is 80 units, but we have supply only of 60 units. So all the 60 units we can allocate it here, exhausting this supply of regular time for the month of January and fulfilling here 80 units we fulfill with 60 units, leaving us with 20 more units to be fulfilled in the month of January. Okay. The next is 125. So we put a box around 125. We have a demand of 20 units for 125 and we have a supply of 20 units. So we can assign it here, exhausting the supply of overtime, fulfilling the demand here in the month of January. So this simply means that in the month of January, I will use 20 units of initial inventory, sell it all. I will use 60 units of regular time multiplied by 100 rupees per unit, and I will use 20 units of overtime multiplied by 125 units, 125 rupees per unit. I am not going to use any subcontracting because by then all the demand that I have for the month of January will be fulfilled. Then we move on to the month of February. So when you are considering February, again look at only the cells corresponding to February. Don't consider any other part of the matrix. Just look at this. From this you have to pick up the least cost. So if we go with the least cost here, it is 5. The demand here is 50. The supply is 0. So we cannot consider this. Go to the next least element, it is 100. So 100 in the month of February, please note that it is not that you have to go directly to February, you have to go to the least cost. So after 0, the next least cost that we have is 100. So if I take 100, I have a demand of 50 units and I also have a supply of 50 units. So I will just fulfill this demand with the 50 units that I have for regular time in February, and this demand becomes 0. This simply means that in the month of February, we are going to use all the 50 units that we have for regular time at 100 rupees per unit to fulfill the demand in February. We are not going to use any overtime, not using any subcontracting. For the month of March, again, only look at the section related to the month of March. Now, here again pick the least cost. It is 10. 10, there is a demand of 70, but we have an issue because we don't have anything in the supply. We cannot use this. The next least cost that we have is 100. 100 has 60 units of regular time to supply to us and we have a demand of 70 units. So we can definitely satisfy part of this demand with the 60 units that we have. This is 0. Remains 10 more units to be satisfied here. Pick up the next least element, which is 125. 20 units are available. 10 units is all we need in the demand. So what we do is we assign this 10 units, fulfilling the demand for the month of March. And here we have 10 units remaining. We have 10 units remaining. So for the month of March, we are going to use 60 units of our regular time at 100 rupees per unit, 10 units of our overtime at 125 rupees per unit to fulfill the demand of 70 that is in the month of March. This is what we're going to do. One more thing that you need to notice here is that in the month of March, 10 units of overtime will remain because we have not used the whole thing in the time period. Now we go on to the next, which is April. So in the given problem, the demand for April is 80 units, but also they have told us that at the end of the time period, which is April, that is 4 months, we need to have an additional inventory of 25 units. So whatever we are doing, we need to keep that in mind. So here, when you are considering April, pick the least cost. Again, in a similar way, if you see, 15 is the least cost, but we don't have a supply. The next least cost is 100. So here you have 65 units and 105 units. Fulfill this demand partially, exhaust this supply. Fulfill this demand, exhaust this supply. So once this is done, you have fulfilled a partial demand over here. So 105 minus 65, this becomes 40 units remaining to be fulfilled over here. And then we go on to find the next least element. Here you have, after 100, you have 105 units over here. That is again the next least element, but we don't have any supply for this. The next least after this is 110. But here again, we don't have any supply. Then you have 115, which again has no supply. Then you go on to see that you have 125, which has a supply of 30 units, but the demand we have is 40 units. So we will exhaust this supply with 30 units here, and 10 more units are remaining in the demand to be fulfilled. So we move on to see what we can do in the month of March again, because we still have 10 units to be fulfilled. So we go to the next least element. After 125, we have 130. So 130, we choose. You have a supply of 10 units. I will exhaust the supply of 10 units. I have a demand of 10 units. I'll satisfy the demand of 10 units here. So in the month of April, to have final inventory 25 plus 80 demand, that is total of 105, we use 10 units which we got from the month of March, which was remaining at 130 per unit, 65 units of regular time and 30 units of overtime. So this is what we have done. Now we move on to the dummy column. So like I told you, we need to make allocations here, whether we are writing zeros or we are adding any other information. So here, from here you just see, when you start with this, again pick the least value. You have so many zeros, we can pick any one. Now if I start with this one, because here this 0, I don't have supply, then I have a 0 here, so I can make an allocation here. 1000 and 4015, 1000 is the least, I will allocate 1000, this becomes 0, this becomes 3015. Then moving on to the next one, we have 0 here, 15 is here, I will allocate 15 because it is less than this, I will be left with 3000. Then the next 0, allocate 1000, 2000 is left. Coming down further, you have another 0, allocate this 1000, you have 1000 left. Then the final one, when you allocate, you have 1000 here, you have 1000 here, so this is 0, that is also 0, and we have completed the allocation of the matrix. Now when you are finding the total cost, it is similar to the transportation problem where you multiply each allocation by the cost that is given for the allocation. Now this is the least cost method of finding the total cost. Also, we will find the total cost, but before that, in the problem, the later part of it states that if at all back ordering is permitted at 10 rupees per unit, then what will the matrix look like? So when you have written the matrix like this is only for forward orders. We are not having any back orders, no backlogs, nothing. So in case there is a back order, that means to say that in January something remained and the people have, in January production was not completed, customers had to wait. So in the month of February, we have to sell what was given in January. So what we need to do in this case is we need to count backwards. At 10 rupees per unit, if at all an order was placed in January but delivered in February, count backwards 10 rupees per unit, which means that 100 will become 110 over here. It's going to cost 110 if there is a back order, 135 if I've used overtime, 160 if I've used subcontracting. Similarly, if at all there is an order that is remaining, so here it will be 110, 135, 160. Why? Because it is a order that has remained. So here if it is from January, then it will become 120, 145, 170. If an order that was supposed to be delivered in the month of January is not delivered till March, I will be spending 120 per unit, 145 per unit, 170 per unit instead of 100, 125 and 150. That is what this means. Then here also it is 110, 135, 160, 120, 145, 170, 130, 155, 180. If an order placed in the month of January is not delivered till the month of April, then I am going to spend 130, 155, 180 instead of 100, 125, 150. If an order placed in the month of March is not delivered till the month of April, I will spend 110, 135, 160 as against 100, 125, 150. So this is when there is back ordering. So when there is back ordering, this is what the table will look like. So this portion of the table gives you the back ordering portion, that is when there is a back order allowed, what will you incur in each month. If this is asked, information is asked, then you need to calculate it backwards, adding the back order cost to each of these terms. Okay. So now what we are going to do is we are going to calculate the total cost of this matrix. So to find the total cost, what we do here is we multiply similar to the transportation matrix. So here we will have total cost multiply each and every allocated cell with the amount and the numbers that have been allocated. So 20 multiplied by 0. Similarly, 6 plus 60 into 100, 20 into 125. So you need to find the sum of all these products. So here we have 20 into 0 plus 60 into 100 plus 20 into 125 plus 50 into 100 plus 60 into 100 plus 10 into 125 plus 10 into 125, then plus 10 into 130 plus 10 into 130 plus 65 into 100 plus 30 into 125 30 into 125 plus 1000 into 0 plus 15 into 0 plus 1000 into 0 plus again 1000 into 0 plus 1000 into 0. One thing that you need to notice here is that all the allocations that are made to the dummy column do not have any significance whatsoever to the allocations or the cost matrix because they are all allocated at 0. So here if you total this, you get rupees 32,000 rupees 32,300 as the total transportation cost. Now with this 32,300 as the total transportation cost, we move on further to create our aggregate plan. What is our aggregate plan? Our aggregate plan is that when we are having the regular time, the overtime and the subcontracting, which deals with our workforce. So if we are going to deal with a constant workforce, what is going to happen? If we vary the workforce size, what is going to happen? All that is what we have to consider here. So when we go with this, we are talking about our aggregate plan, where we are saying that initial inventory of 20 units has to be all sold out in the month of January, and in the month of January further, what we are going to do is we will use 60 units of our regular time, 20 units of our overtime to complete the demand in the month of January. Again, we are going to use in the month of February all the 50 units of our regular time to fulfill the demand in the month of February. In March, we are going to use 60 units of regular time and 10 units of overtime, but we are also going to understand that 10 units of the overtime that we have available is going to remain. So in case it remains, we can use it in the month of April, where we are going to compensate for whatever is remaining in the month of March. And here 65 units of the regular time, 30 units of overtime can be used. So this is a plan that is prepared priorly before we carry out production. Again, one more thing that is very important is that in case there is back ordering, the first case is the forward ordering where no back orders are permitted. If at all there is a back order, which is a pending order, if it is not sold in the month of Jan and it is carried on in the month of February, that means if customers have to wait from January to February, then you are going to spend 110, 135, 160 for each of these kind of orders, and we already know what kind of work we are going to use. We already know that in January we are going to use 60 and 20. Okay, so if we carry out, again you can carry out allocations for this, but it is not necessary. If it is remaining, it is 110, 135, 160 as against 100, 125, 150. Similarly, if a customer has placed an order in the month of Jan, or if a particular production should be completed in the month of Jan, but it is carried on till April, then instead of spending just 100, 125 and 150, you will be spending 130, 155, 180. So that is what this matrix means, and the aggregate plan, this is the chart that is given, and based on this production is planned.